For those of you who believe in evolution, we like to try to change your mind. We got a lot of new people here, so I got to repeat the argument real quick. Okay?
I've heard it.
And what was your name?
Jackson.
Jackson, pleasure to meet you. I'm Eric. This is John. John's from over in the UK, formerly Lebanon. Did you know for 10 years he had to dodge bullets? He literally lived in the middle of a war zone where people were killed every day for 10 years. I mean, this is crazy, man. This guy values life, values truth, values understanding, and wants you guys to have it. He's here because he loves you. Came all the way over from England with his wife because I said, hey, I'm going to be over at UCF October 24th. You want to join me? He said, absolutely. And that's why he's here. So give it up for John being here today, guys. John, thank you for being here, buddy.
Thank you, bro. Thank you.
We're here presenting an argument. Evolution is impossible. We're willing to give away $1,000 to anybody who can prove us wrong. And I'd love to give this money away today because it has big implications, okay? Major implications if evolution is impossible. Let me define our terms real quick, and then we'll have this conversation. Terms. Evolution. I'm not talking about speciation. I'm not talking about variation. I'm not talking about adaptation. That happens. Actually, it was a creationist scientist that discovered this and said, looks like we adapt. Not arguing with that, okay? I'm arguing with an ape-like creature becoming a human being. Macroevolution. One kind of animal evolving into another kind of animal. You're going to be told on your university campus by professors, and I'd encourage you, get your professor to come down here. We'd love to talk to him. We'd absolutely honor that conversation. I've had conversations with many professors. And actually, many professors that know the science will agree, hey, we don't have evidence for macroevolution. We just tell the students, if you give it enough time, the small changes can equal big changes. Here's the problem. We don't have enough time, and that's outside of science. Science is things that we can see, test, and demonstrate. So if it's not observable, it's not scientific. You can't see, it's not operational science. You can't see, test, and demonstrate it. So evolution, I'm talking about what we can see, test, and demonstrate. When I say impossible, we're not talking about theoretical. I'm not talking about one chance out of all the molecules in the universe, 1 to the 150th, or 10 to the 150th.
That's the probability.
Yeah, I'm not talking about probability. I'm talking about scientific plausibility. It does not happen. Matter of fact, genetics keep it from happening. Your genetics correct for errors in the genes. What we do not see is us evolving into something new. What we see is our genetics trying to keep us the exact same thing. Epigenetics is incredible because it showed us that built into our genes, we can adapt to different environments. That's a good thing. You want to be able to do that. Based on your environment, you live in a hot environment, your children's genetics will be better adapted to that hot environment because of epigenetics. That's already designed inside of you. It's not a trait that was evolved or created because you live in a hot environment. So it actually gives incredible honor to God to say, wow, we are incredibly intelligently created. We're made. But here's our simple argument to you today. Evolution is impossible. It was developed by a guy named John Haldane. If you haven't got this paper, we got people walking around with little clipboards and they've got this paper, so you can grab this. Step 1 through 7, I'll walk through it in about 2.5 minutes here. And then, I'm sorry, tell me your name.
Jackson.
What is it?
Jackson.
Jackson. Jackson will get to try to argue against this. Here's our simple argument. According to the atheist or evolutionary worldview, according to the evolutionist worldview, apes are related to humans, and we're about what % different? They used to say 1%, upped it to 2%, then went to 4 to 5%. The more we studied about the DNA, the more we realized how different we are. Current estimates are about a little over 15% different. We're going to go with the original number 1 just to make it easier on evolution. We're going to say we're 1% different from an ape-like creature. Well, the human genome has 3 billion base pairs. 1% of 3 billion base pairs is 30 million genetic changes to go from an ape-like creature to a human being. All we're asking, and actually this was an evolutionary geneticist asking this, he said, how long would it take to make 30 million beneficial mutations? And we're defining beneficial as anything that takes us from an ape-like creature closer to a human being. That's beneficial for the sake of the argument, because we're looking hindsight. They say it happened, so anything that takes us closer to a human being would be beneficial. Now, we're ignoring all the problems. We're ignoring negative, we're ignoring bad mutations, we're ignoring survival rate, we're ignoring neutral mutations. Only good mutations, you'd need at least 30 million of those, because that's how many differences there are. How long would that take? And here's what we discovered. How many beneficial mutations get fixed in a population over time? And Haldane, the guy who studied this on a population of 10,000 individuals, and said with 10,000 individuals, how long would it take? He said to get 1,000 loci, 1,000 beneficial changes, would take 300,000 generations to get fixed in the entire environment. That means every one beneficial mutation is 300 generations. We're not going to do that because that makes evolution really difficult. We're going to make it really easy. We're going to give you one beneficial mutation every generation. Now the question is, how long is a generation? A generation, how long till you have kids? Say again. If you stand up there and talk to us, they sure are. Yeah, here you go, boss. Here you go. Hooking you up. Hey, Santa Cruz, there you go, boss. There you go. How many years till you have a child? About how long till you have a kid? Answers? 20 years. That's what we put down. How many?
It depends on what age we're talking about here, because that's changed over however many centuries.
On average.
Modern day?
Anytime. You give me a number.
Dude, people are getting pregnant like at 15 years old.
Okay, so you want to go down to 15?
Sure.
Okay, so every 15 years there's a new beneficial mutation. Well, you got to get 30 million of them. If you take 30 million times 15, what's your answer?
I don't know.
Well,
come on.
It's a big number. 20 times 30 million is 600 million. 15 times 30 million is 45 million years. You now need 450 million years to go from an ape-like creature to a human with a generation of 15 years.
Yeah.
Haldane, the evolutionary scientist, said, we don't have that much time. We're in trouble. It's known as Haldane's dilemma. It's never been resolved. It's still a problem today.
Not true, actually.
That's what we want to find out. So you got an argument for us against it. Tell me, I'm sorry.
Actually,
no.
To a lot of people. Okay, so Haldane's theorem.
Jackson's going to give us an argument. Go ahead, Jackson.
Haldane's dilemma already got solved, actually, a while ago with the neutral molecular theory. So, if you got anything against that?
Can you talk a little bit closer in the mic? Can you describe that for us?
Oh, yeah. So basically, what happened was that with Haldane was working with like really basic Darwinian and Mendelian genetics, and so most of molecular evolution. That's not true. That was the molecular. That was not. Yeah.
Hey Jackson, go ahead and give us your argument. What's your argument? Go ahead.
Excuse me.
Go ahead and give us your argument.
I'm looking at what you're setting up already, but anyway. Basically, the reason is that his formula is very wrong in that it uses very outdated, genetics and evolutionary things. Where Kimura was a Japanese similar geneticist, who resolved it. He ended up resolving it, and it proves that most, genes are actually randomly fixed, and a lot of it is neutral, which drastically reduced the cost of Haldane's theorem. Or Haldane's
so let me
dilemma.
ask you something, Jackson.
Sure.
Are you trusting what he wrote, what this Japanese scientist wrote? Are you trusting what he said?
Oh, now we're being semantic because you're trusting what Haldane wrote.
Right, well, I'm asking you a question. Your argument is somebody came up with an argument against it, and I'm trusting his argument. Is that correct?
Yeah.
Okay, good.
Okay, Jackson, thank you very much. I have to say you're the first person who Googled it, at least.
Thank you.
So thank you.
It took an hour.
It's okay. Exactly, it doesn't take more than 10 seconds to actually Google something.
Well, you got to understand. You got to understand it first.
Yeah, we got to understand it first, but you don't. You just go to Wikipedia and it gives you the answer.
That's not a good way to base evidence. Otherwise, you don't know.
Yeah, I agree.
If you don't understand the arguments that you're making, then
they're
ridiculous.
You're doing that right now.
Excuse me?
You're doing that right now.
No, I understand. I
You're
understand
doing that
the
right now.
theorems.
You Googled something.
Yeah.
You said there's an argument against it and said it's done.
I sat down with the theorem. I explained the theorem to you.
Okay.
And I broke it. I broke Haldane. Actually, I didn't. Kimura did. Kimura did.
Go.
Okay. Jackson, thank you very much for bringing this. I was wondering how long it's going to take before somebody actually Googles this thing and finds out some answers. So, Jackson, thank you very much for doing that. I'm going to try to be as brief as possible. This is it. This is right there. It's not like I haven't actually checked it and you surprised me. There are other answers to Haldane's dilemma I'm waiting for somebody else to bring up.
Sure.
There are actually only two. Motoo Kimura in 1968 thought, hey, listen, guys, he's right. Haldane is right. What does it mean if I say Haldane is right? That means... no, wait. I'm going to give you the answer because I know the answer.
But he didn't
if
say
Haldane is right, if he is right about the solution, then Haldane was right to discredit beneficial mutations and natural selection. Because Motoo Kimura agreed with him, and Motoo Kimura had to come out with a different solution. And this is basically what happened. He agreed, he said, look, rapid selective evolution requires an unrealistically high rate of beneficial mutation. You guys, have you been told in school exactly what Motoo Kimura said? He said, unrealistically high rate of beneficial mutation is 100% correct. In other words, Haldane, you've done a good job. I love it when students stand up there.
Yeah,
hey, listen,
except for
I'm answering the question.
Okay, but
I don't know what else you're going to say. You've already said Motoo Kimura came up with the solution. I'm giving you the answer of Motoo Kimura.
Yeah, that's not.
So if I'm going to give the answer for Motoo Kimura, you have to wait and listen. Yes?
Sure.
Okay, so Motoo Kimura agreed with Haldane. That means when you go to your school later on, you should be listening to your professor saying, hey, listen guys, natural selection doesn't work anymore. That's what you should be hearing. But you don't hear that, do you? And most people who stood here to refute what Haldane said, in my opinion, he's wrong, when actually Motoo Kimura agreed with him. So I think we can basically agree that, and this is what happened the moment he came up with that. He said, natural selection no longer works. That means selectionist and survival of the fittest is not the way we came into being. He basically said neutral mutations. Through genetic drift is why things change from one thing to another. That's why green bugs change to yellow bugs. That's why birds can fly purely because of neutral mutations. That means by pure coincidence a bird can fly. So that means all these things came about purely because of neutral mutations. This is what he did that nobody knows. He actually changed the definition of words. And that's why Walt Riemann had to come later in 1993 to explain what he did in order for you guys to understand that he didn't solve the problem. He changed the word to substitutional load rather than substitutional cost. And that makes a big difference. You know why? Because when Haldane tried to work out the figures, he said, this is what I have and this is what I get. While Motoo Kimura came along and he said, well, this is what I need, therefore this is what I want. So he changed the definition from cost to load that nobody understood. So what does it mean? Well, he changed the definition to get a number of 182 neutral mutations. Ladies and gentlemen, go and ask your professor, do we get 182 neutral mutations fixed in the population today? The answer is no, of course not. That will be a disaster. Why would it be a disaster? Because 90% of neutral mutations change to become harmful. That means you go from 182 neutral mutations to end up with 164 harmful mutations the moment it's expressed. That means the moment it's passed on to the DNA to become a protein, it becomes 90% harmful. You know how bad that is? That's 164 times higher than the rate that would cause error catastrophe. You only need one harmful mutation to be fixed in the population every generation for you to destroy humanity. Yeah. This guy ended up with 164. That's why Walt Riemann came along in 1993 and he said, guys, he didn't solve the problem. The truth is, there is no solution to this. Only solution you can come up with is one that makes the population be destroyed. Is that what you want to do? You want to destroy the population? Guys, spend more than an hour or 10 minutes or 60 seconds looking at a solution before you tell me that there is a solution. Jackson.
Yeah.
Did you know about this?
Some of it I did. The other parts are a little misconstrued in that I don't think you quite understand the
I don't wait.
I don't think so.
Wait, guys, did you hear what he just said? He said, I don't understand it. When I just quoted other scientists here, I did not say this is my view. Yeah. I am not the one you're rebutting. You just say these words again. You just say these scientists have got it wrong.
I'm accusing you of not understanding the theories that you're putting out here, and instead you're going, this is a scientist, he's right, instead of actually looking in and reading it.
So do you
understand that? Yeah,
Jackson. So what is your argument against this?
My argument is that the number is wrong and it's derived from a bad equation that doesn't use more modern things that we've learned about genetics.
Okay, and where do you get those figures from? What are the correct figures?
I looked into Haldane's formula a bit. He uses very basic Mendelian.
Can I just stop you for a second?
No.
You're talking about Motoo Kimura. Tell me how Motoo Kimura got those figures wrong.
No, I'm talking about Haldane. I'm being very specific with this, is that I looked in Haldane's theorem. He's using basic Darwinian, evolution and Mendelian genetics. We've moved past those theories and thought processes, and that the modern theories of evolution are not the same as Darwin's, right?
Okay, Jackson.
Right?
You told me the solution to Haldane's dilemma. You're telling me you disagree
No.
with Haldane, and
Okay.
I understand that. You stood there and you told me Haldane's dilemma has been resolved. Everybody, you heard Jackson say Haldane's dilemma has been resolved, and the evidence for that is Motoo Kimura. Now we've gone back to Haldane. Are we talking about? Are we talking about Motoo Kimura who solved this dilemma, or are we going back to Haldane who you disagree with? Do you disagree with Motoo Kimura as well?
Please don't feign any ignorance. I've been very specific about that. I'm moving to Haldane and I'm moving through Kimura.
Okay.
So please don't. You know that I'm speaking about Haldane right now.
I'm trying to, yeah.
I know. I'm working with you. And that there's a lot of things like, polymorphism. You're familiar with that, correct?
Sure.
Right. Haldane's not.
So what, pardon?
Haldane is not.
Haldane is not what?
Familiar with polymorphism.
So what exactly is polymorphism? Well, it's just a fancy way of saying that some genes have multiple versions that are common in a population. A gene is considered polymorphic if at least 1% of a population carries a certain variation. Polymorphisms help keep genetic diversity within a population. The more genetic diversity there is, the better the chances that some individuals will be well suited to survive changes in the environment. But polymorphisms don't actually create anything new. They just shuffle around variations that already exist in the genetic code. But to solve Haldane's dilemma, we need new genetic material, and that only happens through mutations. So what are mutations? Well, mutations are changes in the DNA that happen when cells copy their DNA or when they're exposed to things like radiation or chemicals. These changes can show up in different ways, like substitutions, insertions, deletions, inversions, duplications, and translocations. So when it comes to Haldane's dilemma, polymorphisms don't really solve the problem because they are just rearranging what's already there. But if we're trying to explain major evolutionary changes, then what we actually need are new mutations, not just variations of the same old genes. And that brings us to whether Haldane even knew about polymorphism. Well, of course he did. John Purdon Sanderson Haldane knew all about genetic polymorphism. In fact, he was actually one of the pioneers of population genetics and evolutionary biology. Back in the 1920s and 30s, he worked alongside Ronald Fisher and Sewell Wright, helping to lay the mathematical groundwork for how genes spread and stick around in populations. Although he didn't come up with the term genetic polymorphism, because that was coined later by E.B. Ford in the 1940s and 50s, John Haldane was fully aware of it because his paper came out in 1957, and his research was all about how genetic variation is maintained over time. In his paper, which ultimately led to Haldane's dilemma, he considered a lot of factors, including the cost of segregation, which is technically defined as the extra reproduction rate required for maintaining polymorphisms in the population. So we know for sure Haldane did take polymorphism into account.
There is more than just dominant and recessive alleles that just decide for this character type. That is what Haldane...
Did he know that?
Huh?
Did Haldane know this?
Haldane is worked off of basic Mendelian genetics, which is what I was speking about earlier.
You want me to show you? You want me to show you the things you took into consideration?
Huh? Yes, please. I've read it. Yeah, I've read it.
This is everything he knew about.
Bring me the formula
Before.
Bring me Haldane's formula.
Okay, Jackson, do you know the formula?
Huh? Yeah. So the formula basically comes off of using these dominant and recessive alleles and only factoring for those things. We know now that there's way more than just one or two alleles.
And we don't have a problem with that. That is not mutation that changes something.
Oh no, I'm not arguing that. I'm not arguing that. But I'm saying the discovery of that does break Haldane's. Yeah. I'm arguing Haldane's dilemma.
We don't agree with that.
It's outdated.
Yeah.
I mean, you've heard 1934. There was the French aeronautic who basically went through and looked at things and was like, hey, by all laws of aviation, bees can't fly. That is not just from the bee movie. That's a real thing that happened. By the laws of aviation, bees can't fly. I'm saying the same thing, and what you're saying to me, especially with this whole evolution is possible thing.
Can I
No, I'm not done yet. I'm going to finish my point first.
All right.
And what you're saying is that instead of like, oh, maybe the laws are here a little bit more little need to be tweaked. You're like, the bees don't fly.
Okay.
And the bees don't fly because I can look at the fossil record. I can look at everything else that prove that it's a pretty good evolution. Yeah.
So can I now respond to you?
Please.
Okay. Dominant and recessive DNA and alleles makes no difference to whether we go from ape-like creatures to humans.
It makes every difference.
No, it doesn't. Only if you have mutations. You have to have mutations in order for these things to make a difference.
So where do the mutations come?
These recessive and dominant alleles need to work on something, and what it works on is mutations.
They work right. Well,
no, wait. Yes, it does. Yes, it does.
Otherwise, it's already in the gene.
Otherwise, it's already in the gene.
That's like saying the human DNA was already in the ape, and there's not 30 million changes. changing allele frequencies and turning certain genes on and off doesn't turn an ape-like creature into a human being. That's what we're saying. That's what Haldane was saying. You have to actually work on something. You have to create new genetic changes, mutations. We're looking at anything from an ape-like creature to a human being, saying that's beneficial.